Hi, today we're going to talk about scale factor. So I've drawn some shapes on the board, and these shapes represent some original items and some new items. So we're going to start by looking at these two bottom shapes, the two rectangles. And the first shape we have has dimensions of 20 inches by 60 inches, and this is my original. Let's say this is the size of a portrait that we have, a picture. And we want to make that bigger. We want it to cover much more of the wall. So we're going to increase the size of it, right? So we're going to make it larger. So we've talked about before the fact that if we keep something proportional, it means we increase corresponding sides by the same amount. So I'm increasing 60 by some number to get 300. I'm increasing 20 inches by some number to get 100 inches. And the scale factor, what it is it tells us what am I increasing or decreasing this by. So when we talk about scale factor, we use this. The scale factor is equal to the new over the original. Okay, we're going to be using that a lot. So let's look at this first diagram here. And what we're going to do is we're going to look at corresponding sides. So I'm going to make a little table here. And first I'm going to put my new and my original. Right? And let's line up corresponding sides. So in the new, I have a side that's 300 inches. And I also have a side that's 100 inches. So I'm going to put that in my table. Now what side corresponds to the 300 inches in the original? The 300 inches corresponds with the 60 inches in the original. The 100 inches in my new corresponds to the 20 inches in my original. So what I've done is line them up. Now I want to see what the scale factor that it's increased by is. So if I'm increasing it, I'm going to have a scale factor greater than 1. So if I increase the size, my scale factor will be more than 1. Okay. Later we'll look at a case where we decrease the size, and the scale factor is less than 1. But let's start here. So if I'm going to find out what the scale factor is, if this is proportional, it should be the same value that we multiply 60 by to get 300, and that we multiply 20 by to get 100. So some of you can probably do that in your head, but what we're going to do is we're going to systematically write it out. So here, for my first corresponding side, the 300 inches to the 60 inches, my new is 300. Rewrite that so you can see it on the screen. So we have 300. That's my new. My original is 60, correct? Okay, we're going to use my shortcuts in math here, where I can cross out a 0. I now have 30 divided by 6, which gives me my scale factor of 5. So for this first one, my scale factor is 5. So we can test this by seeing if I multiply 300 by 5, do I get 6? I'm sorry, if I multiply my 60 by 5, do I get my 300? Yes. If I multiply my 20 by 5, do I get my 100? Yes. So the scale factor here is 5. I would expect it to be greater than 1 because I've made an image larger. So next we're going to look at what happens when we make a shape smaller. Again, we're going to use the idea of scale factor here. Let's say that we have a garden plot here that's a triangular with these dimensions, with 10 inches on one side. I guess that's a really small garden plot, but let's pretend that we're just trying to make a shape smaller rather than a garden plot. So 10 inches on one side and 16 inches on another side. And what we're trying to do is we're going to make a picture of that is smaller than what it is in reality. So if I have one side's 10 inches, let's go ahead and make our table. My new and my original. So the 10 inches corresponds with the 5 inches of the new triangle. So under the new, I'm going to put 5. Under the original, I'm going to put 10. I also have another side given. I have 8 inches on my new and 16 inches on my original. So I'm looking at what am I multiplying my original by to get my new. Okay? So if I'm looking at it like this, from my original to my new, I'm actually decreasing size, right? So when I'm getting smaller, I'm going to have a scale factor that is less than 1. Okay. So let's think about this. So if I'm going from 10 to 5, what am I doing here? I'm actually dividing it by 2, right? So from dividing something by 2, I can guess that my scale factor is going to be 1/2. Let's check this out. So if I put my new on top in my equation, so my 5 over my original, 5 over 10, if I reduce that, divide each by 5, I would get 1/2. So what I'm doing here is I'm multiplying 10 times 1/2, and that will give me 5. So to do the multiplication, 10 times 1/2, I put a 1 underneath the 10 times 1/2, I can cross cancel. My 10 becomes a 5, my 2 becomes a 1, and I get 5. So I see that it works for that side. Let's check it for the other side, the other sides that are corresponding. So my new was 8, my original was 16. Does this also reduce to 1/2? In fact, it does. I get 1/2. So what that's saying is if I have 16 and I multiply it by 1/2, I'm going to get 8. Let's do the math. I can cross cancel 16 and 2 to get 1 and 8. 8 times 1 is 8 over 1, which is 8. So it works that my scale factor here is 1/2. So oftentimes when you're looking at a map, or if you're looking at a figure that's been increased or decreased in size, the scale factor is telling you the proportional constant by which it's increased or decreased in size. So we'll be working more with this in class, but I wanted you to have a little introduction to it. That concludes the video.